Welcome Stefan, that today we will talk about some technology he developed in Meran. So I think it will be pretty interesting. So thank you Stefan, and the floor is yours.
Thank you. I'm Stefan Mutschlechner, the head of the public lighting department of the Stadtwerke Meran. I make not only public lighting, for this reason I'm here, I'm also making some smart city projects. Why we use open source? The public administration must make a technical and economical comparative analysis for choosing the software. We have to use software for other public administrations, and we have to use open source. That's written in the Codice Amministrazione Digitale, Article 68. Theoretically, in this article is written that public administration, if we find an open source solution which is on the same technical level like a licensed solution, we must select the open source solution. Stadtwerke Meran, we are using open source and we are creating open source software. For this reason, I'm speaking here because it's really important that other cities knows what we are doing, and theoretically they should also use our solutions. Another reason why I'm here is to demystify Lorawan. To create a Lorawan network infrastructure is relatively simple and possible also for smaller cities like Merano. Theoretically, I am the smart city department of the Stadtwerke. At the moment, I'm alone, but I was able to create the network. It's possible to create the Lorawan network by using open source. For the moment, we have realized 4 use cases. We have realized smart lighting. We have realized smart metering for our water counters. We are making temperature measuring, and we are GPS tracking our waste containers. What is Lorawan? Lorawan stands for Long Range Wide Area Network. Long range means that we can transmit up to 15 kilometers in rural areas. In urban areas, we can transmit until 1 kilometer. For this reason, I have installed in Merano on every square kilometer 1 gateway. Low power, that means that we can operate up to 10 years on battery power. That's, for example, it's really important on the water counters because we cannot cable every water counter in the basements. The low data rate means that the Lorawan device is sending a data package, and a typical data package is around 50 bytes. And the last really important point for Lorawan is once the infrastructure is installed, there are no additional costs. Obviously, there are the hosting costs, but we have not costs per device. How is working the Lorawan infrastructure? We have devices in the field. They are sending the payloads, and the payloads can be received by multiple gateways. That's one of the strong sides of Lorawan, because if I have one Lorawan gateway offline, it's not a problem because maybe 2 or 3 other gateways can receive the uplink. The gateways are forwarding the information to the network server, and the network server is providing the data to the application server over MQTT or over an API. That's our Lorawan network in Merano. We have first installed 5 gateways on high precision. Every gateway has its own 4G modem and its own firewall. We have installed these 5 gateways around the city. and it works well with 50, 60, with 200 devices. When we have installed the first 1,000 devices for the smart lighting, we had problems. And for this reason, I have added in the urban area 13 gateways, one gateway on every square kilometer. We sometimes find out that it's still not enough, but for us to install additional gateways, it's really easy. You can see here all these black points. These are our electrical cabinets. We have connectivity in all these 71 electrical cabinets. At the moment, we have a 4G modem in every cabinet, and we will bring in the next year also the fiber there. If we need an additional Lorawan gateway, it's really easy. We install in this electrical cabinet a PoE injector, run a network cable to the nearest light point, and install there a Lorawan gateway. That's the network plan of our electrical cabinet. We have the 4G modem. We have our OpenSense firewall, which is connected over a VPN client to the cloud. Then we have just inside the PLC for controlling the electrical cabinet, and we connect the Lorawan gateway to the firewall. On the picture, you can see a typical installation on a light pole from a gateway. What is the chirp stack? The chirp stack is an open source Lorawan network server. The network server receives uplink packages from the gateways, sends the downlink messages by selecting the most suitable gateway for the transmission. And the data is made available via MQTT or API. The configuration of the chirp stack is really easy. The first step is when I have about a device, I have to create the device profile. The easiest way is to click on this blue button to load the device profile template, and the device profile is created. It's also possible to do it manually. You have only to insert the name, to choose between OTAA or APP join mode. OTAA means that the Lorawan device is sending a join request, and the network server sends down the key for the connection. On the APP, the device has just the key, and it's less secure, but you have less traffic. Then you can choose class B or C. For example, the lamps are class C devices. That means these devices are always listening, can always receive commands, and are continuously powered by an energy source. A class A device is battery powered and is only listening for 2 scheduled time windows after the transmission. One really important point for me on this point is the codec. On the codec point, you can insert JavaScript for encode the payload. Normally, if you buy a device, in the documentation you have just the finished JavaScript, you copy it inside, and after you can see just your values. Then the next step after creating the device profile is to create the application and add the device. In the case of an OTAA device, you have to insert the name, the device IOE. The device IOE is the unique ID for every Lorawan device in this world. Then you press submit and insert the excuse me, it was too fast. You press submit, you insert the application key, and that's all. It's really, really simple to add a Lorawan device to the chip stack. From the field to the cloud, we, like Stadtwerke Meran, we are able to choose the device, to install the device in the field. We are able to configure the device on the chip stack. Obviously, if you have 1,000 devices, we are not making it manually, then it's possible to make it via API. We are able to make available the data. That means that we successfully bring the data from the field to the cloud. That's really important for us. We have no software developers in Stadtwerke Meran. The software development and the integration to our smart city platform are making external companies. The one use case is the smart lighting. It's the biggest use case. In Meran, we have 6,200 light points, and we have installed on 1,009 light points controllers. We can make the configuration of the dimming profile. That means if, for example, the energy cost is going up, we can regulate the dimming profile that we make less light in the night for spending less money. The lamp controller is a Class C device with continuous listening and gets the power from the lamp driver. It gets 24 volt. We are getting the status of the lamp every 2 hours, and our electricians in the morning can export a report and know on which lamps they must make a maintenance. Then the smart metering. The smart metering are Class A devices. They are battery powered. We have installed 50 smart meters in Graz. It's a small part of Meran. Smart meters are sending the counter value 2 times a day. They are installed in basements and in manholes. For this reason, the communication is really difficult. But of the 50 installed smart meters, 45 are responding. In 2025, the first customers will receive their water bill based on the data read by Lorawan. For the Just Nature project, we have installed 36 auto microclimate stations. We are measuring relative humidity, temperature, and air pressure. These are also Class A devices. They are battery powered. The sensors are used to analyze the correlation between vegetation and air temperature. And we have found out where we have a lot of trees, we have lower temperatures, and a lot of trees are good are a good preparation against the climate change. The last use case, what I have realized, is the GPS tracking of our waste containers. We have 40 press containers are used for the large customers like supermarkets. These waste presses can be delivered by our trucks to different customers. And we have the problem that for regular maintenance, we have to know where they are. And for this reason, we have installed a GPS tracker. The GPS tracker is also a Class A device, battery powered, and is sending 1 time a day the position, or if it's moved by the truck. Thank you.
Stefan, for the presentation. Are there any questions from the audience? Okay, there's one.
Only one question for the... a question for the smart meters. when a customer has that in his basement, can he also access the data? For example, if he has smart home or house automation at home, can he also access the data, or is that not linked in any source to the customer?
He at the moment cannot access to this data, but theoretically it's possible, because we are sending the data to a MQTT broker, where the company who is making our bills is getting the data. Theoretically, we can make also account for a citizen.
Okay. Thank you very much.
One more. Can I?
Yes?
30 seconds.
I saw that the payload is really small. Did you take some tests to understand how much can you do a bigger transmission? 1 kilobyte of data or more?
No, we have for the moment we have worked with the devices for the lamps, for the smart metering. We have worked with these devices, and there the payload is not bigger. I don't know if there exists devices with such a big payload.
Okay. Thank you very much.